Hi everyone, welcome to another session for Bitcoin kernel. Uh, Bitcoin kernel is, extracting out the consensus engine from Bitcoin core, or you can say that's the consensus engine for the Bitcoin protocol. And today we'll be looking at another language bindings. Previously, we have seen uh, Rust Bitcoin kernel, which is the Rust bindings for Bitcoin kernel. Now we'll be looking at py-bitcoin kernel or Python bindings for Bitcoin kernel. So, why does the language bindings exist in the first place, and why do we need the language bindings? As I've discussed in the previous session that, language bindings exist because, you have a lot of we have a lot of projects that requires Bitcoin consensus engine or basically Bitcoin validation logic. And the project might be in different languages such as Rust, in Python, in Java, in Golang, in .NET as well. So for that reason, the language bindings exist so that you don't have to deal with all the C, because the in or the upstream header or basically the library is written in C and C++, and we don't want to deal with the C and C++ code, and you don't want to convert your Python code to C code or stuff like that, and all the memory management. So for that reason the language bindings exist, so that you can leverage the consensus engine or basically the C consensus engine library using the language bindings of your choice. For example, Python, we can use the Python Bitcoin kernel, and everything is written in Python. You can use this and you can just get on with that. So today's structure will be we'll be discussing about what is Python Bitcoin kernel and what all exists in Bitcoin kernel, and we'll code a bit. We'll just code the context free checks. Context free checks means you don't require the whole blockchain state, because to fully validate a block or a transaction or script, not script, but yeah, for block and for the transaction you might need the previous transaction history and or the previous block history. So for that reason, now we'll be just focusing on the context free. So there are a lot of consensus checks that don't require the whole blockchain state. For example, validating whether the header is under 80 bytes, and whether that block has the header has the target lower than the difficulty and stuff like that. And also script verification, whether the script is spending this transaction, or basically whether this script pub key is spending this transaction. So we'll be looking at that. So before that, let us see the py-bitcoin kernel. This is the py-bitcoin kernel, which is maintained by Stickisv or Stephen, and it's currently in alpha stage. Since we don't have any we don't have any release for the C library, so that's the reason why we are in the alpha stage for all the language bindings. But yeah, maybe very soon we'll be releasing the Bitcoin kernel library, and then all the language bindings will be having their own separate releases. So this is the py-bitcoin kernel, and the docs are here. And yeah, so py-bitcoin kernel, in short, it's also written as PBK, is a Python wrapper around libbitcoin kernel, or Python wrapper bindings for libbitcoin kernel, which provides the Pythoning interface while handling the low C types. So it's like you don't have to deal with the C types, or basically C types is actually the code in Python which does the communication with Python code as well as the C code. Like it helps in communicating with the C code through Python code, and memory management as well. Yeah, so you can use this Python Bitcoin kernel, and you can deal with the Bitcoin kernel or the Bitcoin kernel library and all the features that the Bitcoin kernel has. Uh, py-bitcoin is actively maintained by Stephen. We have all the features and all the changes that is there in the C library, such as logging, uh, as well as the block block features, like if you have a block, then if you want to extract out the block hash, you want to extract out the block header, the transaction, and convert that hexadecimal into bytes. And there are lots of methods that you can use this. We have for block hash as well, and block header as well. Block header was recently merged in Bitcoin Core, or in the this Bitcoin kernel library, where you can validate whether this block header is valid or not, and extract out all the fields of block header, like bits, basically n bits, and block hash, nonce, previous hash, timestamp at which the block was mined, the version of the block, and yeah, that's it. And block tree entry as well. Each block is stored as an entry in the memory. Memory means RAM, and like, so that you can index the block very fast. I mean, you don't have to fetch each block from the disk, which is kind of slow. And for that reason, each block is also stored at RAM, but not the whole block, like not the whole transaction with the block is not stored in the memory. Only summary of the block, such as the block hash and block header, and how many transaction it has, stuff like that. So it's stored in the memory, so that you can index or you can fetch the block very fast. You don't have to call the disk again and again. And then we also have the chain API. uh, you know Suppose you have a whole data directory and you want to check, or basically you want to see what is the current block of your chain or the data directory that is stored in your own system has. And you can do that with block map. It's like a dictionary kind of interface that helps reading from the disk of the system, or basically the data directory. And block spent outputs as well, for reading all the undo data. And undo data means, if a block has been mined, and what was the mempool state before this block was mined. So that's the block undo data. and and block tree entry as well, like you can just fetch the block from the RAM using this block tree map class. And context, this is very helpful when you want to create a context. For example, what does context means is that you want to specify the context. Like, suppose you want to suppose you want to use the consensus engine, and what is the current state of the network, like if it's red test it, if it is mainnet or signet or testnet 4. You have to maintain that. And for that reason we use the context options, or context. And with context option you can specify what is the chain params, basically what is the type of the network. If you want to set the notification, like if you receive a new block, so you want to validate that block, what is the status of the block, whether it's valid, invalid, or whether it's uh, whether it has failed some validation check, what was the status of the block. And validation interface as well. For example, there are lots of validation flags that you want to you know uh, provide, like if this block has proof of work set or correct, if it has the Merkle root in correct form, something like that. There are lots of flags. And context, it's like creating a context from the context options. You specify the requirements of your context, and then you create all the requirements, or you set all the requirements through context options, and then you create a context from the context options. Yeah. So as you can see here, you can initialize a context using the context options. So context options, uh, to specify the set chain parameters, set notifications if you want the notification, set the validation interface, what all validation you might need. And then uh, uh, there is the context free check for script as well, or basically script API as well, which does all the script verification. What is the whether this script is has valid check log time verify, whether it has valid check sequence verify, whether it is dersig, none, null dummy, p2sh, whether the script is taproot, or whether this is witness, basically segbit. Then you can also specify script verify status. Whenever you validate a script, you in return you get the script verify status, which is actually the status of the script, whether this what was the error of the script. Currently we only have 3 script verify status, but there are lots of script verify 3, whether this script has valid or invalid flags, and what is the, if there is error in the spent outputs of the script, what is the, why this script was valid, or basically why this script was invalid. If it's invalid, and if it's valid, then it will just return the script verify status will be okay. And then you can also create the script pub key, and you can just pass the bytes of the script pub key, or even if you have the hex value of the script pub key, you can convert from hex to bytes, then pass the bytes. And yeah, we have the verify method that helps in verifying whether this script spends this transaction, or basically whether this transaction spends this script pub key. That's more accurate. And for that you might need the amount uh, and the transaction bytes, pre-computed transaction data, the input index as well, the flags as well. So for the today's session, we'll be looking at verifying script, because script verification doesn't require any uh, context of the blockchain, or basically the whole blockchain state. We don't need that. So we'll just be looking at script verification, and we'll also be looking at the block header deserialization that was just a couple of weeks ago. It was merged in the library, and then it was also implemented in py-bitcoinkernel. Yeah. For the transaction, currently the transaction validation is not context free. You will be needing the blockchain state, because verifying a transaction requires the previous transaction as well. So for that reason, we'll be needing the uh, previous transaction history. So that's why the transaction is not context free. It is contextual, and there is also a PR for the context free transaction. Not sure when that will be merged, but if that is merged, we'll be we'll be discussing about that as well. Yeah. So only the script verification is actually context free for now, but there are transaction as well, there are context free checks as well for the transaction, and there are context free checks for the blocks as well. So if that is merged, then we'll be looking at that code as well. So yeah, let's begin with uh, some coding stuff. uh, so you might need to clone py-bitcoin kernel, and then create a virtual environment, and then activate the virtual environment, and then you can install py-bitcoin kernel with something like this, pip install, and like this. So I've already done that. So now we'll be looking at uh, this is a script hex in hex form, and the amount, the transaction in hexadecimal form, and the input index. So to verify a script with respect to a transaction, we will need all these four fields: the amount, the transaction hex, the script hex, and the input index. And later on we'll be dealing with block header, and since block header is also not context free, so but we can deserialize the block header and see all the fields of the block header, like what is the n bits, what is the nonce, stuff like that. All right, so let us see the docs first. Yeah. You can also use the Bitcoin kernel logger as well for logging whether this transaction or block or script was valid or not. So you can use the logging to see what is the validation status of the block or the transaction that you are passing it to the consensus engine. But for this session we'll be just looking at the script verification, which doesn't require any uh, previous blockchain state and doesn't require the logging as well. All right, so after you have installed the py-bitcoin kernel, you can just import using ppk, import ppk. And first we'll be verifying a script. So let us create a function, verify script. And yeah, so what all fields we need? We need the transaction hex, the amount, pre-computer transaction data, and if if you don't want to provide the pre-computer transaction data, then you can just provide none, or you don't need to provide none because it's already specified with the or bit operator. If it's not provided, then it's not a big deal, because the Bitcoin kernel automatically computes the pre-computer transaction from transaction data. Pre-computer transaction data is actually computing the transaction data like early, so that the script verification is actually very fast, becomes very fast. I need to provide the input index. uh, I need to provide the flags as well. uh, you know like how you want to verify, or what all fields you want to supply to the verifying script. So there are lots of flags. Yeah, I've already discussed. We have all check, sequence, verify, null, dummy, taproot, and witness. So we'll be using segwit and see whether this transaction is valid or not. So basically, whether this script hex is spent by this transaction or not. So we'll be needing a script pub key hex, and that should be in string format, and the amount will be in int, transaction will be in hex form, and what else? Input index. So if you don't provide any flags, then by default uh, it will be all. Yep. Yeah, it will be all. uh, so this should return boolean value, and Now let us, since script verify requires all these fields in hex form, or not hex form, in bytes form. So for that reason, not bytes form, but in script pub key form, like the script pub key class that we have here, and then we'll verify with respect to that. And will also need to convert this to the transaction format. Transaction, it's actually a Python class, so we need to convert the hex string to bytes, and from bytes to the Python py-bitcoin kernel transaction type. So let us convert the script pub key hex string to the type of script pub key. We'll convert using the already provided Python uh, bytes module. So bytes from hex, and we'll provide script pub key hex. Now we also need to convert this transaction hex string to the py-bitcoin kernel transaction type. So similarly, we'll pvk transaction bytes from hex. All right, so we have converted the script pub key hex string to script pub key type, and the transaction hex to transaction type. Now we'll just run the script pub key verify. So script pub key dot verify. We need to pass the amount. So amount is in integer form already. Okay, we need to provide the amount value 0, and next is the transaction tx2, and then will not provide the pre-computed transaction data. Let us make the Bitcoin kernel compute by itself. We'll provide the input index, uh, index, and then we need to provide the script verification flags as well. So you can provide with script verification flag. So since this script pub key and the transaction is not taproot, so we'll remove the taproot from here, and we'll just provide everything, but everything other than the taproot. So we'll just remove script verification all, and from script verification all, we'll remove the taproot script verification flag dot. Yeah, so I think this is enough. We provided the input index and provided the transaction type, amount as well. Now let us check using the print function, verify script. We need to pass this value, the script hex string value. We'll just copy that and paste it here. We need to provide the amount, which is 0, and then we need to provide the transaction hex. What is the input index? That is 0. Sorry. Yeah, so this is, I guess, complete. Yep. So let's try to run it. So let's try to run it. Python script.py. All right. So we're getting some error. Um, okay. Verify script. Passing amount here, passing transaction to hex. Okay, I think we need to provide here none as well, because not providing any pre-computed transaction data. Yep. So yeah, so if you see, we need to provide the none as well, because we are not providing the pre-computed transaction data. So this is actually a valid script. So let us copy this script and paste it here as well, and we'll just change some value. Let us change from 999 to 000, and now this should actually fail, or it should show, I mean, it should show 0, because this is not actually a valid transaction that spends this script pub key. So yeah, if you see here, then it's printing 0. So that means this script is actually invalid, or basically the transaction is actually invalid. All right, so now we'll create another function, which is deserialize block, block header. So here we'll just pass block header as hex string, and yeah, so block header just needs uh, Okay, block header just needs the raw block, and we'll create a block header from the raw block data, and from that we'll deserialize all the block header. We'll see what is the n bits, what is the block hash, what is the nonce, all the stuff. So we need to create the block header block hex string to the type of block, to the type py-bitcoinkernel block header. So for that we'll convert that from bytes, because it requires the bytes value. So again, pvk dot block header will provide here bytes. Now we'll print all the fields of the block header. Yep, actually, it's not block. You can create a block header from block raw data, but uh, for this session, we'll be using a raw block header hex string, and then we'll be, seeing all the fields that this block header consists of, all the version, timestamp, nonce, and previous hash as well. So we'll print the n bits. Uh, Block header dot, I guess, bits. Bits. So bits, and we'll print the block hash. And then we'll print the nonce. And what else? Previous hash. And timestamp and version. Okay, so now let's use this. We'll use deserialized block header. We'll paste here this value. Now this should deserialize the block header from this hex string. So let's run this one. Yep. So as you can see, there's the n bits, or the bits of this block header, and this is the block hash. nonce value, the previous has the timestamp of this when this block was, validated or basically mined, and the version. So mind that this is actually a context free, so we are not actually validating the block header here. We are just deserializing the block header. So whatever value you provide, so the Bitcoin kernel will actually deserialize with respect to the data that you have provided. Yep. So I'll just push this one. So I've pushed this code to to the Bitcoin kernel GitHub repo, and if you want to see, then you can just check this Bitcoin kernel repo on GitHub. I pushed it now, just now. So yeah, that was it from my side. If you have any question, then you can just ask.